Okay, welcome back guys to my stream. I know no one's watching, but the stream is for myself, but I'm just gonna talk to myself again. So, we are back with our series on portswigger labs. So, we finished 2 labs already. That is the path traversal and the server-side vulnerabilities. Oh wait. Okay, I'm back. So, we finished those 2 labs, and today we are gonna finish the file upload vulnerabilities. I hope I finished this path I mean. Today, okay. Nice. So, as usual, I'm gonna take notes and I want to show it to stream, but I'll try to explain as best as I can to you guys if you are watching. And yeah, let's get started. Ooh, there are actually a lot of the what do you call this? Materials. A lot of materials. So I think I'm gonna take a lot of notes. Wait, let me set up my notes first. Okay, that's nice. Let us start then. So what are file upload vulnerabilities? File upload vulnerabilities are when a web server allows user to upload files to its file system without sufficiently validating things like their name, type, contents, or size. Failing to properly enforce restrictions on this could mean that even the basic image upload function can be used to upload arbitrary and potentially dangerous files instead. This could even include server-side scripts that enable remote code execution. So we actually did that before on the server-side vulnerabilities path, but I think that's just the opening. So this path will be like more in-depth about the topic. So yeah, in some cases, the act of uploading the file itself enough is to In some cases, the act of uploading the file is in itself enough to cause damage. Other attacks may involve a follow-up HTTP request for the file, typically to trigger its execution by the server. So in this case, it's similar to what we did yesterday. Remember the PHP web shell that we uploaded? We need to open the file in our browser to execute it on the server. Yeah, that's basically the same situation. Let me copy this to my notes. Okay, so knowing we are learning about vulnerabilities, the most important thing about the vulnerabilities, the impact. So let's continue. So what is the impact of file upload vulnerabilities? The impact of file upload vulnerabilities generally depends on 2 key factors: which aspect of the file the website fails to validate properly, whether that be its size, type, contents, and so on. What restrictions are imposed on the file once it has successfully uploaded. Yeah, so the first problem is that we have to know is which filter is broken. Like, is it the one checking the size, the type, the contents, or other stuff? And the second thing that we have to know is what are the restrictions? Can we run the web shell like without doing anything, just a simple web shell. Can we run it? Can we not? Yeah, I don't know how to explain. In the worst case scenario, the file type isn't validated properly, and the server configurations allow certain types of files such as PHP and JSP to be executed as code. In this case, an attacker could potentially upload a server-side code file that functions as a web shell. Yeah, this is what we did yesterday, effectively granting them full control over the server. Yes, so these are the two key factors that we need to think when pen testing or bug bounty or doing a bug bounty. Let's copy that. Okay, let's continue. What is the impact of okay, but this one is continued, so let's read it. If the file name isn't validated properly, this could allow an attacker to override critical files simply by uploading a file with the same name. Yeah, imagine if I uploaded a index.html, I could change the HTML page, the index page of the website. If the server is also vulnerable to directory traversal, this could mean attackers are even able to upload files to unanticipated locations. Failing to make sure that the size of the file falls within expected thresholds could also enable a form of denial of service attacks, whereby the attacker fills the available disk space. Yeah. Interesting. Maybe the attacker could upload a zip bomb, then unzip it using the web shell. That will be catastrophic. Okay. How do file upload vulnerabilities arise? Given the fairly obvious dangers, it's rare for websites in the wild to have no restriction whatsoever on which files users are allowed to upload. More commonly, developers implement what they believe to be robust validation that is either inherently flawed or can be easily bypassed. Yeah, they trust their own code too much. For example, they may attempt to blacklist dangerous file types, but fail to account for parsing discrepancies when checking the file extensions. As with any backlist, it's also easy to accidentally omit more obscure file types that may still be dangerous. Yeah, they could miss like 2 or 3 file types that are dangerous because they are using a blacklist. In other cases, the website may attempt to check the file type by verifying properties that can be easily manipulated by an attacker using tools like burpsuit or repeater, or proxy or repeater. So yeah, this is the interceptor, and repeater is basically the ones that you can repeat a request. Ultimately, even robust validation measures may be applied inconsistently across networks of hosts and directories that form the website, resulting in discrepancies that can be exploited. Yeah, this is actually very true, because in a big company, you will have like tons of websites that, yeah, like thousands of websites. So, yeah. Yeah, what I meant is they can have like thousands of websites, so inconsistency is very common. Okay, let's continue. How do web servers handle requests for static files? Before we look at how to exploit file upload vulnerabilities, it's important that you have basic understanding of how servers handle requests for static files. Okay. Historically, websites consisted almost entirely of static files that would be served to users when requested. As a result, the path of each request could be mapped one-on-one with the hierarchy of directories and files on the server's file system. Nowadays, websites are increasingly dynamic and the path of requests often has no direct relationship to the file system at all. Oh yeah. Nevertheless, web servers still deal with requests for some static files, including style sheets, image, and so on. The process of handling these static files is still largely the same. At some point, the server parses the path in the request to identify the file extension. It then uses this to determine the type of the file being requested, typically by comparing it to a list of pre-configured mappings between the extensions and map types. So we can actually like confuse the MIME checker. We could put like I don't know how much, but like a 4 byte to make the MIME types checker think it's another file. What happens next depends on the file type and the server's configuration. Wait. Okay. If this file is non-executable, such as image or static HTML page, the server may just send the file's contents to the client in an HTTP response. If the file type is unexecutable, such as a PHP file, and the server is configured to execute files of this type, it will assign variables based on the headers and parameters in the HTTP request before running the script. The resulting output may be sent to the client in an HTTP response. If the file type is executable, but the server is not configured to execute the files of this type, it will generally respond with an error. However, in some cases, the contents of the file may still be served to the client as plain text, such as misconfigurations can occasionally be exploited to leak source code and other sensitive information. You can see the example of this in our information disclosure learning materials. Let's check the tip. The content time response header may provide clues to what kind of file the server thinks it has served. If this header hasn't been accessed by expression code, normally contains the result of the file extension type mappings. Now that you are familiar with cancels, okay. So what this means is the third one. It's very interesting. If you configure a server to not run anything, when you open a server-side file, like an executable file, like a PHP, then it won't run, but it will show us the code. Yeah. So I think this is the start of the labs. So we are exploiting a unrestricted file uploads to deploy a web shell. From a security perspective, the worst possible scenario is when a website allows you to upload server-side scripts such as PHP, Java, or Python files. Yeah, and it's also configured to execute them as code. This makes it trivial to create your own web shell on the server. Yeah, web shell is what we did yesterday. So if you're able to successfully upload a web shell, you effectively have full control over the server. So this is very bad. This is like a 10.0 CVSS, like the highest. This means that you can read, write arbitrary files, exfiltrate sensitive data, even use the server to pivot attacks against both internal infrastructure and other servers outside the network. For example, the following PHP one-liner can be used to read arbitrary files from the server's file system. Yeah, this is the one that the community used and the intended use to solve the yesterday's problem. Once uploaded, sending a request to this malicious file will return the target shell contents in the response. A more versatile web shell may look something like this. Yeah, this is the one that we used yesterday, the one with the double output and was very annoying. This script enables you to pass an arbitrary system command via a query parameters as follows. Yeah, so this get command will take a parameter, see here, this is the parameter, and it will take the ID and put it into system, so it will run ID on the Linux. Let's continue. Okay, so I think this is the one that we solved before, but let's solve it again for fun. Wait, let me check something out. Wait, where is it? I forgot where I put the... Is it here? No. Oh, it's here. So let me open my WSL again. So let's read the challenge. To solve the lab, upload a basic PHP web shell to get the Carlos secret. Yeah, you can log into your account. Okay, winner Peter. Let's log in and see what we have. Peter. Wait. No. Winner Peter. Yeah, slight typo. So let's try uploading an image. Wait, let me open another. As usual, let's try uploading a Patrick image and upload it, and it works. So as you can see, it was saved at files and avatars. So let's try uploading our web shell from yesterday. This is the web shell. It's basically the one that the example showed us. So let's try uploading it. Can upload, then open the image. Then if I'm correct, then the server is giving us access to the shell.php. Let's type the command, and where am I? Carlos. So let's view contents of this. So we have to find the duplicate. So okay, nice. Then you can submit a solution to the challenge to solve it. Yeah, nice. So exploiting flawed validation of file uploads in the wild, it's unlikely that you will find a website that has no protection against file load attacks, like we saw in the previous lab. But just because defenses are in place doesn't mean that they are robust. You can sometimes still exploit flaws in these mechanisms to obtain a web shell for remote code execution (RCE). So, flood type validations. When submitting HTML forms, the browser typically sends the provided data in a post request with the content application x www form URL encoded. This is fine for sending simple text like your name or address. However, it isn't suitable for sending large amounts of binary data, such as an entire file or a PDF document. In this case, the content type is multipart or form data. Consider a form containing fields for uploading an image. Providing a description of it, entering your username, submitting such a form might result in a request that looks something like this. So yeah, the one that we have to see is the content type header. So it's giving the multipart form data is the PDF. Yeah, so here the second one it's sending an image, and the third is just a form data. As you can see, the message body is split separate parts for each of the form inputs. each part contains a content disposition header. This is the header probably, yeah, which provides some basic information about the input file types, input field it relates to. These individual parts may also contain their own content type header, which tells the server MIME type of the data that was submitted using this input. Yeah. One way that websites may attempt to validate file uploads is to check this input specific content type header matches an expected MIME type. If the server is only expecting image files, for example, it may only allow types like image JPEG or image PNG. Problems can arise when the value of the header is explicitly trusted by the server. Yeah, because the attacker could intercept the request then change the header. If no further validation is performed to check whether the contents of the file actually match the supposed MIME type, this defense can be easily bypassed using tools like burp repeater. Yeah. Let's boot up our burp sheet. For this challenge, I think we need burp now. Okay, let's wait. Let me drink. So we can open our browser. Then access the lab. So let's read what this lab is about. So I think we solved this yesterday also. Yeah, so it has a formable image upload function, basic PHP web shell to, yeah, it's the same, but this one relies on checking the user controllable input to verify this. Okay, let's take a URL. And the account is Wiener Peter again. Okay. Let's log into the account first. Wiener Peter. So let's check now. What if we upload an image? What happens is, let's put it on our repeater. As you can see, the content type is called image.png, so the server accepts the file. Yeah, but what if we upload a shell? See, the server won't accept this file type because only image JPEG and image PNG are allowed. So what happens if we upload the shell again, but we can intercept the request, then change the content type into the one that we have on the repeater. So change this part, then forward. Why is it lagging? Back. Then can we access it though? Matching new tab. Then command is to cat which part of the file again? Oh yeah, this part. Yeah, we solved it again. Then we can submit it to the solution to solve the challenge. Nice. Okay, now to the next topic. We still have a lot, but we are halfway finished. Preventing file execution in user-accessible directories. While it's clearly better to prevent dangerous file types being uploaded in the first place, the second line of defense is to stop the server from executing any scripts that do slip through the net. As a precaution, servers generally run scripts whose MIME type they have been explicitly configured to execute. Otherwise, they may just return some kind of error message. In some cases, serve the contents of the file as plain text instead. Yeah, if you can see here, the attacker is trying to run the same exploit that we did, but instead of the server giving the output of the command ID, it just returns the contents of the file inside of exploit.php. Yeah. This behavior is potentially interesting in its own right, as it might provide a way to leak source code, but nullifies any attempt to create a web shell. Yeah, because if you ever have access to index.html, then you can index.php, then you can leak the source code of it. This kind of configuration often differs between directories. A directory to which user-supplied files are uploaded will likely have much stricter controls than other locations. In other locations on the file system, they are assumed to be out of reach for end users. If you can find a way to upload a script to a different directory that's not supposed to contain user-supplied files, the server may execute your script after all. Web servers often use the file name field in multi-part form data request to determine the file name and location where the file should be saved. You should also note that even though you may send all of your requests to the same domain name, this often points to reverse proxy. Servers of some kind, such as a load balancer, requests will often be handled by additional servers behind the scenes, which also be configured differently. So this time we have a web shell via path traversal. This tab contains a vulnerable image upload function. The server is configured to prevent execution of user-supplied files, but this restriction can be bypassed by exploiting a secondary vulnerability. To solve the lab, upload a basic page to website and use it to exploit something in a second. Okay, so I think this is gonna be a bit hard. So let's read it again. So this one is actually a bit interesting. So let's try solving it then. So let's log into the winner account again. Winner heater. Then let's upload a basic image and check what happens in the behind the scenes. So this file name is actually a bit interesting. So let's just forward it first to the server. Wait, what? And see where the file is served. When I mention new tab. So it's served at files and avatars. So I don't think the server will allow any files to run on files avatars Patrick. But what if we did this? So let's remember it's files avatars, but what if we uploaded the image? So I thought of this like 5 seconds ago. What if we, where's the name? Let me search it. Wait, what did I press? Let me try that again. What if we put a dot slash here? Dot slash. What will happen? This is what I thought about. What's happening? What happens? So it doesn't go back to avatars. This is weird. I thought the files. Hmm. So it doesn't work like that. Interesting. I thought that would work. Hmm. Interesting. What if we just do var in the review HTML slash. Can we access it then? Not found. So this is a bit interesting. Is that not the... That's actually a bit interesting. So it did work. But the image is not there. Interesting. So when I get back to my account, it will break. What if we try uploading the shell then? If we open the image in new tab, it will probably just provide, yeah. But what if we put the shell at a different place? Let's try. Shell.php. Wait, not here. Doesn't work. So this is a bit weird. I don't understand why this doesn't work. I stupid? Well, let's read the. Wait, is there static on this website? Let's try. What if we just do static Charlotte's PHP? I don't think static works like that. Am I cool? I'm a bit confused on how to solve this, so let's just view the solution. Oh yeah, why didn't I think about that? Okay, so I understand what I'm facing now. So because it says avatars that show the PHP, why doesn't it work? Because as you can see, this should go back one directory from avatars, but it didn't. So this should mean it's filtering it. Man, I'm so stupid. Let's try bypassing it. The first one still. So let's try a URL with this URL coding. Oh, it's the code. Okay, I'll just boot up the CyberShaft. Will this work? Wait, that's weird. Oh, so it worked. Let's try the command. Who am I? Yeah, it worked. Okay. So I was a bit stupid. Sorry, guys. So let's just cut this part. And complete the challenge. So why didn't I didn't expect it to have like a filter, because I thought this one was a easy challenge, right? Because it's one of the first ones that we are faced with, the newer ones. So I didn't expect it to have filters. So this is a new one for me, but it's very a stupid blunder for me, because I should have known it. But yeah, we are humans, I guess. Okay, let's refresh it. Nice, we have solved it. So the next one is insufficient blacklisting of dangerous file types. So okay, one of the most obvious ways of preventing users from uploading malicious script is to blacklist potentially dangerous file extensions like .php. Like yes, the ones we use. The practice of blacklisting is inherently flawed, as it's difficult to explicitly block every possible file extension that could be used to execute code. Such as blacklists can sometimes be bypassed by using lesser-known alternative file extensions that may still be executable, such as PHP 5 or as HTML, and so on. As we discussed in the previous section, servers typically won't execute files unless they have been configured to do so. For example, before an Apache server will execute a PHP files requested by a client, developers might have to add the following directives to their etc apache 2 conf file. Many servers also allow developers to create special configuration files within individual directories in order to override or add one or more of the global settings. Apache servers, for example, will load a directory-specific configuration from a file called .htaccess if one is present. Okay, so from my understanding is what the path is explaining is if you are using a Apache server and we are trying to execute a PHP file, then the developers will have to add this into the configurations of the Apache for the server to have PHP on them. And the second one is Apache servers usually have a configuration file called .htaccess. So this is an important file. Overriding the server configuration. Similarly, developers can make directory-specific configuration on IIS server using a webconfig file. This might include directives such as the following, which in this case allows JSON file to be served to users. Web servers use these kinds of configuration files when present, but you're not normally allowed to access them using HTTP requests. However, you may occasionally find servers that files to stop you from uploading your own malicious configuration file. In this case, even a file extension unit is blacklisted, you may be able to trick the server into mapping arbitrarily custom file extension that an executable MIME type. Trick the server into mapping an arbitrary custom file extension to an Oh, so we could trick the server. Like if I create my own extension called .audic, we could possibly make the server think to execute it as a PHP. Interesting. Web shell upload via blacklist bypass. This lab contains a vulnerable image upload function. Certain file extensions are blacklisted, but in this kind of defense can be bypassed due to a fundamental flaw in the configuration of this blacklist. To solve the lab, okay. Let's try solving it without a hint first. So it's using the same account again, right? Yeah, winner Peter. So first, let's try uploading our Patrick as usual. Let's try sending it. Why is it not working? Oh, it's working now. So it's basically the same as for uploading the second part, shell. What would happen? Let us see. Sorry, PHP files are not allowed. Sorry, there was an error uploading your files. So knowing that the server is using PHP, maybe it's using an Apache. So maybe let's try accessing the htaccess, and it isn't found. Interesting. So is there certain types of LFI? Why is the server not giving any response? I don't understand. Wait. Okay, so it's now giving me a response. What if it to trick it into still avatars? What if we put a URL encoded so it doesn't work like that? So there's no LFI. What if we double URL encoded? I'm just joking. This will probably doesn't work, but let's try. Yeah. Bummer. So what can we do here? So is there really no htaccess? What about robots? No? Really? What about other PHP file types? P457. So if we try uploading it as .php, the server will reject it. So hopefully the server gives us a response. Where's the response? I'm waiting. Okay, all out. What about PHP 3? Oh, so it's this is interesting. What if we try uploading an image as PHP 3? Interesting. Let's try changing to PHP 3. Forward. Interesting. When we open the image, no, it doesn't work. But good to know. What if it doesn't support PHP 3? Let's try PHTML maybe. I'ma just like do a repeater Let's try there. Then let's just repeat it. Where is the name? PHP. So what are the file types? 457 4 5 7 8 and also PHTML. So let's okay. HTML is rejected. But what about PHP with an S? Okay, let's try it now. So now PHP is forbidden. Interesting. What about PHP 8? Nope. 7 5. Yeah, it doesn't work. 4. So PHPS actually works, but we don't have permission to access it. Let's try PHP. Doesn't work. So the one that works actually just gives us a forbidden. So I'm a bit confused. Let's try hint. You need to upload 2 different files to solve this lab. So I think we need to like change the htaccess somehow, but I don't feel like we have a LFI, so let's check the solution. But isn't htaccess not available? Isn't here? Don't say. Oh, there's actually htaccess. Who puts the htaccess on avatars? That's so weird, man. Okay, so let me solve this myself then. Access example. Extensions. PHP to custom. Maybe this will give us. Oh, interesting. So let's try using this one. So we can just, if this works, then it should be easy to solve. I thought there was no htaccess file, but it's actually there. I just didn't check, so it's my fault. So let's try intercepting the shell. And let's check. What if we call it htaccess, then have the input. Yeah. Let's call it arc. Nice. Then if I'm correct, if we upload a .arc file, it should be a PHP file. The server will treat it as a .php. Nice. So let's try. Then where's the place that we have to? Okay. Let's try. Command cat. So it doesn't work. Oh no, typo. Nice, we solved the challenge with a slight hint. So my fault. I didn't check because I didn't expect the .ht access file to be inside of the images directory. That's so weird. It was usually stored at the base of the directory, right? At the root. So let's claim. Yeah, that was actually a bit hard because I feel like it's a bit guessing, but I feel like it's because I'm just a noob. Obfuscating file extensions. Even the most exhaustive can potentially be bypassed using classic obfuscation techniques. Let's say the validation code is case sensitive and files recognize that exploit.php is in fact PHP file. If the code that subsequently maps the file extension to MIME types is not case sensitive, this discrepancy allows you to sneak malicious PHP files past validation that may eventually be executed by the server. Yeah. You can also achieve similar results using the following techniques. Provide multiple extensions depending on the rhythm. Yeah. Interesting. At trailing characters, some components will strip or ignore trailing white spaces, dots, such as like using URL encoding, or dots, or such as value is encoded. Okay. At semicolons or URL encoded to null byte characters before the extension. If validation is written in a high-level language like PHP or Java, but the server processes the file using lower level function like C or C++. For example, this can cause discrepancies in what is treated as the end of the file name. Oh, interesting. Try using multi-byte Unicode characters, which can be converted to null bytes and dots after Unicode conversion or normalization. Sequences like may be translated to if the file name parsed as UTF-8 string but then converted to ASCII characters before being used as a path. Interesting. Let me actually save this to my notes because I feel like this is a good part of the note. Take the header as well. Let me have a sip. Obfuscating file extensions. Other defenses involve stripping or replacing the extensions to prevent them. If this information isn't applied recursively, you can position prohibited string in such a way that removing it still leaves behind a file extension. For example, consider what happens if you strip.php. Yes, this is similar to the LFI one, right? The one when we strip the dot slash, it's this one. 4 dots with double slash. They will strip the middle part, then they will leave this part. It's the same. This is just a small section of many ways it is possible to obfuscate file extensions. Okay. So let's try accessing the lab. all the it's all the empower. Okay, let's try solving it now. Interesting. So winner repeater again, right? Yeah. So it's probably the same. Wait. Okay, so this is probably the same challenge again. So let's try uploading a Patrick image again. Our beloved Patrick. Yeah, it's basically the same. It's so many errors. Yeah, it's the same. But what if we uploaded a PHP file? What would happen? Sending it to repeater. Drop. Only JPEG and allowed. What if we upload it as PNG? What happens? Will the server... Oh, it doesn't work. Let's check our notes again. What if we... Nope. This one is actually interesting. What if we do it like this? So the doesn't work. What about null bytes? Oh! It became shell.php. Is this it? Whoop! Ooh, okay, we actually solved that challenge very fast. Okay, that's nice. I didn't expect null bytes to solve the challenge, man. That was actually a bit fun because we did it so fast. Let's check. Did we solve it? Yes, we solved it. Nice. Okay. There are 5 more, but I think I'm gonna take a break first. Like a 10-minute break. So, yeah. Okay, hello guys, I'm back. So, continuing the path, we have 5 more rooms to complete, then we finish the file upload path. Okay, let's continue. Flood validation of the file's content. Instead of implicitly trusting the content type specified in the request, more secure servers try to verify the contents of the file that actually match what is expected. In this case of an image upload function, the server might try to first verify a certain intrinsic properties of the image, such as its dimensions. If you try uploading a PHP script, for example, it won't have any dimensions at all. Therefore, the server can deduce that it can't possibly be an image and reject the upload accordingly. Similarly, certain file types may always contain a specific sequence of bytes in their header or footer. This can be used like a fingerprint or signature to determine whether the contents match the expected type. For example, JPEG files always begin with the bytes FF38FF. So this is actually very common in forensic challenges in CTFs. You can find like magic byte headers files. Nih, this is the one probably. Yeah, you could find, like if you want to find JPEG, then it will give you the headers. So all of this will turn to be JPEG and GPG. This is a much more robust way of validating file type. But even this isn't foolproof. Using special tools such as Exif tool, it can be trivial to create a polyglot JPEG file containing position code in its metadata. So this is interesting. Polyglot JPEG image. Interesting. I want to put this at my notes so I can find it, like research it more. Because interesting. I didn't know that you could create a polyglot JPEG. This lab is learnable. Yeah. Okay, it's the same. Let's try solving it. Hopefully it won't be that hard, but if it's hard, I'm cooked. Okay. So as usual, I'm pretty sure we are given the winner Peter account again. Yeah, the same account. So let's try uploading our usual Patrick first. Okay, it's accepted as usual, but what if we uploaded a shell.php? It's the same Peter valid image, but what if we put a PNG here? Sam. Still isn't accepted. Maybe it's because of this, but let's try uploading a Patrick again and view what's called account or image PNG. Let's try image/PNG. Doesn't work. Why is it not working? I think this is the one that the challenge is asking us, a polyglot. Let me try to research that then. Okay, let's try this one. So it's basically let me try copying the Patrick. Interesting. So let's try uploading that. Peter. Did it work? Hello? So it actually works. But can we run? Can we run the image though? Command. Where am I? So it doesn't work. This is the one that I tried, right? So let's try creating it. So the logic is we try to track the mime type, mime checker. The image will, the checker will view this part and think that it's an image. What? Huh? No, it's method not allowed. What's happening? Try uploading the path track again. What's happening? Is it my... Oh, it's my Windows Defender. Wait, let me pause it. So I think that my Windows Defender deleted the file, so that's why it's broken. So let us try to upload it again. So it's still not a valid image. That's a bummer. This is the one we are solving. So I got leaked, man. So I was in the correct technique, but I didn't do it right. So let's try getting the PNG. So we can use that technique, right? So start creating it. Echo cat shell, echo poly. To poly.php. Let's call it ENN, right? Yeah. Let's put the bytes done. We can copy this part. Then create the poly. Yeah, it has the bytes. Oh, the server accepted though. Oh, it accepted. So I tried doing that, but with the JPEG, I didn't expect it to like check the 8 bytes. I was a bit stupid. I should have used this website. I'm pretty sure the JPEG one should also work. But why isn't the PHP commands working now? Okay, I think I need to view the solution. No, but I did that before, but it doesn't work. I tried doing that, right? Oh, I think it's because I use command, not CM. Oh, that's probably the problem. So let's try doing that then. Try echo, like the same type of. Yeah. No. Let's just. I don't think we even need the echo. I'm pretty sure this will also work. So remove that one. Let's try. And hopefully we'll get. Please. I'm a bit tired already. So let's try doing CMD. Who am I? Then find Carlos. Oh, it actually works. Ah. So why did I say that we don't need the start and the end? Because we can also do this. Then just cut the secret. Cut the secret. Then also do another who am I. So it will be in the middle. See? It will be in the middle of the names. So then we can submit the solution and we solve the challenge. So we actually already solved the challenge, but I was using the wrong parameter. So actually I already found the vulnerability, but I was a bit, yeah, I read it wrong. I didn't like I didn't read the code very well. Like I didn't notice that it was using CMD and not command. Yeah, it's my fault. My bad. Yeah, that was fun. Let's check if we solved it already. Yes, we solved it. Okay, so now continuing. Exploiting file upload race conditions. This sounds interesting. Modern frameworks are more battle hardened against these kinds of attacks. They generally don't upload files directly to their intended destination on the file system. Instead, they take precautions like uploading to a temporary sandbox directory first and randomizing the name to avoid overwriting existing files. Interesting. They then perform validation on this temporary file and only transfer it to the destination once it deems safe to do so. That said, developers sometimes implement their own processing of the file uploads independently of any framework. Not only this is fairly complex to do, well, it can also introduce dangerous race conditions that enable an attacker to completely bypass even the most robust validation. So, what the path is explaining is this part is this time the defense is before we upload it straight into the static images, right? But this time we will upload it to a temporary directory first, then check it, then after it feels like it's safe, it will upload it into the static image directory again. So this can cause problem when we upload an image, then we access it from the temporary directory. Yeah. For example, some websites upload the file directly to the main file system, then remove it again. If it doesn't pass validation, this kind of behavior is typically in websites that rely on antivirus software and like to check for malware. This may only take a few milliseconds, but for the short time that the file exists on the server, and the attacker can potentially execute it. These vulnerabilities can often are often extremely subtle, making them difficult to detect during black box testing unless you can find a way to leak the relevant source code. Similar race conditions can occur in functions that allow you to upload file by providing a URL. In this case, the server has to fetch the file over the internet and create a local copy before it can perform any validation. Oh, this is interesting, yeah. Because imagine if we give the server a very large file. When the server takes the file from us, it will take some time to download it. So in that time, we could do a rest condition to exploit it, yeah. As the file is loaded using HTTP, developers are unable to use their framework's built-in mechanisms for securely validating files. Instead, they may manually create their own processes or temporarily storing and validating the file, which may not be quite as secure. Race conditions in URL-based file uploads continued. Oh, interesting. For example, if the file is loaded into temporary directory with a randomized name, for example, in theory, it should be impossible for an attacker to exploit any race conditions. If they don't know the name of the directory, they will unable to request the file in order to trigger its execution. On the other hand, if the randomized directory name is generated using pseudo random functions like PHP unique ID, it can potentially be brute force. Yeah, this is a problem, but it will take a lot of time. To make the attacks easier, you can try to extend the amount of time taken to process the file, terribly lengthening the window for brute forcing the directory name. One way of doing this is by uploading a larger file. You see, like I said before, if you upload a very large file, then the server will take more time to take it because they need to download the file from us, right? If it is processed in chunks, you can potentially take advantage of this by creating a malicious file with the payload at the start followed by a large number of arbitrary padding bytes. Yeah, very cool. Three more. So, exploiting file upload vulnerabilities without remote code execution. Wait, let me drink. In the examples we have looked so far, we have been able to upload server-side scripts for remote code execution. This is the most serious consequence of an insecure file upload function, but these vulnerabilities can still be exploited in other ways. Oh, this is interesting. Let me copy this because from my knowledge, all I know is the server-side files only. So this could give me a new information. Let's try continuing. So Uploading malicious client-side scripts, is it like XSS? Although you might not be able to execute scripts on the server, you may still be able to upload scripts for client-side tasks. For example, if you can upload HTML files or FPG images, you can potentially use scripts to text. Yeah, sort. Yeah, this is cool. If the uploaded image appears on the page and that is sufficient by users, the browser will execute the script and render the page. Not due to the same origin policy restriction. This kind of attacks will only work if the uploaded files is served from the same origin to which you uploaded. Copy this. Interesting. Exploiting vulnerabilities in the parsing of uploaded files. If the uploaded file seems to be both stored and served securely, the last resort is to try exploiting vulnerabilities specific to the parsing or processing of different file formats. For example, you know that the server parses XML-based files such as Microsoft Office .doc or XLS files, which this may be a potential factor for XXE injection attacks. Interesting. Ooh, these infos are okay. The second last one. Uploading files using PUT. It's worth noting that some web servers may be configured to support PUT requests. If appropriate defenses aren't in place, this can provide an alternative means of uploading malicious files even when an upload function isn't available via the web interface. Oh, interesting, because you could view all the headers of the requests that you can use, and if PUT is available, you could try to upload in a file. Yeah, cool. Interesting. I shall put this on my notes as well. And also the example. Why is it white? Wait. Let me open my notes, sir. Yeah, I don't want to leak my notepad because I have a lot of stuff there. So I need to pause a bit. Tip, you can try sending options, requests, yeah. So yeah, options is the one to ask the server what are the methods that we can use when doing a request. So the last path, finally, we finish it. How to prevent file upload vulnerabilities. Allowing users to upload files is commonplace and doesn't have to be dangerous as long as you take the right precautions. In general, the most effective way to protect your own website from these vulnerabilities is to implement all the following practices. Check the file extension against a whitelist permitted extension rather than blacklist of prohibited ones. It's much easier to guess which extensions you might want to allow than it is to guess which ones the attacker might try to upload. Make sure the file name doesn't contain any substrings that may be interpreted as a directory or traversal sequence. Yeah, this is from the second one, right? That we did the ones that we have to URL decode, but I forgot about URL encodes because of I didn't thought that it would contain like a URL decode function. Rename uploaded files to avoid collisions that may cause execution files to be overwritten. This is the case from the .htaccess, right? It's problematic because if we don't rename the uploaded files, we can also like change the index.html, and that will lead to a lot of bad stuff. Do not upload files to the server's permanent file system until they have been fully validated. This is the same, but we need to have a good random, or can load it to a temporary file. This is a bit complex because we need to have a good random. This is the one from the race conditions, right? As much as possible, use an established framework for processing file uploads rather than attempting to write your own validation mechanisms. Yeah, this is a good one because most of the problems comes from the ones that created them themselves. Yeah. Dang, we finished the file upload. Yeah. Finally, after 1 hour and 50 minutes, 48 minutes to be exact. So that's it for today. We finished it. We finished 3 already. 5 server solve, 5 upload vulnerabilities, and also server set vulnerabilities. I don't know which one I'm gonna do tomorrow, but I'm saving the most for last, I think, because it takes lots of time. Imagine 35 like the room site, but it took me almost 2 hours. But the labs are not even that much. There are not many labs in the path. It took me almost 2 hours to finish. Imagine a 51 room. Or 65. Yeah, prototype pollution though. Understandable. 55 to authentication. There are so many rooms that has so much room. There's many. What am I doing, man? Why am I speaking? There are so many paths that has so much rooms. So many rooms. But yeah, that's it for today. Thank you for watching. If you are watching, thank you. That's it.